Now we want to show how is the derivative of the inverse function. Let me start with a simple example. Consider a function f of x is 2x. Here is the graph of this function. And the corresponding inverse. If the function is multiplication by 2, then the inverse is division by 2, or multiplication by half. The graph looks like that. This line has the steeper slope than 45 degrees, and this is less, the angle is less than 45 degrees. Now the derivative of the function is 2, and the derivative of the inverse is 1/2. The derivative is the coefficient that is used to multiply change of the argument to get the change of the result. If you change x by some amount, then the result will be 2 times larger, the change. And here, if you change the argument of the function by some small amount, then the change of the result will be 2 times smaller. And this is always the case. If f expands, then inverse shrinks, and vice versa. If the derivative were negative, so the derivative of the inverse function would be negative as well. In general, it is so that f derivative times f inverse derivative is equal to 1. This can be shown by considering the composition f inverse evaluated at f of x is equal to x. Perhaps to some condition for x. And if we differentiate this result, then we have here the composition. That means f inverse, or yeah, if we differentiate, we can close it into bracket and differentiate, and this is f inverse differentiated at f of x times f prime, and the derivative of x with respect to x is 1. And that means that the product of the derivative of the inverse function and the derivative of the inverse function is 1. So the derivative is 1 over f prime. F inverse derivative at the point f of x is equal to 1 over f derivative x.